for I equals to 1, okay, I is lesser than n, I equals to I multiplied by 2, do something and close. So this is my for loop. So now we need to calculate the complexity of this piece of code. Okay. So we will do the same thing. What is my I equals to 1. Let's imagine n is 8. Just take example as n is 8. So to make this condition as false, how many times I need to repeat my as a I, how many times I will loop through. So here my increment is I equals to I multiplied by 2, right? So that means what will happen? I is initially 1, after that it will be multiplied by 2, after that what it will do? Again it will multiply by 2, 1 multiplied by 2, another time it will multiply by 2, right? So next time 1 multiplied by 2 multiplied by 2, another time it will be multiplied by 2. See, what exactly we are doing? Initially my I value is 1, right? So after that in next increment I equals to I multiplied by 2. What is my I? I is 1 multiplied by 2. So next time it will do? The result of this value, multiplied by another second time. So after that what will happen? The result of this value multiplied by another 2. So this will go on up to what? At some particular point of time this condition will fail. So we need to see. If you observe here, we can come up with some idea. See, this is 2 power 2, right? I can write it down as 2 power 1. This I can write it as 2 power 3, right? So 1 multiplied by 2, 2 power 1 equals to 2, 2 power 2 equals to 4, 1 multiplied by 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8. So if I do this, now this entire piece is this and we will multiply with 2. So how many times? We are multiplying 2 with 2 power 4 times. What will be the value? 60. So while this comes my condition will fail, right? So but the pattern is how we are doing 2 power 1 or 2 power 2 or 2 power 3. Here 2 is same because we are multiplying with 2. But when the value above on top of this value the power value increases, at some point of time my condition will fail. So in this case 3 is my condition. 2 power 3 will become this condition will 2 power 3 is 8. 8 is lesser than 8. Wrong. So right, while my for loop comes to this point, my condition will satisfy and it will break, right? So now because my n is 8, so I know how up to which point it will loop. But if for example, if my n is some n number, let's imagine n. Now at some point of time, 2 power something is lesser than n will fail. That some point of time, let's imagine it is k. Just imagine instead of 3 I am just replacing with k, some imaginary, some number. So that what I am saying exactly, when 2 power k comes, my condition will break. So this will become like this, so that this condition will be break, right? So now what I got? 2 power k equals to n, right? You understood, right? Let's see. I hope you understood, right? This one. Okay. See, simply I am multiplying. After that I got a pattern, and what is my pattern? 2 power something. So up to which power I need to do this? up to k power, so that this condition will break. So I came to this position. Now 2 power k equals to 1. So instead of 3, I am just making it as k, so that we will get some generalized complexity to calculate because as of now n is 8, but n can be anything, right? N can be any number. So to make that generalized, to calculate the complexity of this algorithm, so instead of 8 I am representing n, and instead of 3 I am just replaced with used k. Okay, so what exactly this means? 2 power k, when I am repeating this step, when I placed instead of k 1, I got 2 and my condition satisfied. When I place 2, my condition satisfied. But when I place 3, my condition failed and I will stop my execution, right? So that k is 3 here in this case. When my n is n, then my k is 3. Okay, so now if you observe 2 power k equals to n, this can be represented in logarithmic fashion also, right? So initially when we started, we learned about logarithms, right? That time I said we will utilize logarithmic functionality in our while calculating complexity of algorithm, right? So now what I have, 2 power k equals to n. How can it be translated, represented in logarithmic fashion? Log n base to equals to k, right? 2 power k can equals to n can be represented as log base to n, right? So what is I am left with what? This is my complexity of this program, that can be big O of log to n. So my complexity of this program for loop is big O of log to n, right? I hope you understood clearly. For I equals to n, I is greater than 1, okay, I equals to I by 2. Do something. So this is my another for loop. Okay. So what will be the complexity of this? Let's do the same thing. What is my I? Let's imagine n is 8. For example, my n is 8. So my I also, I equals to n. So my I also will be 8. Okay. So after that what will happen? I equals to I by 2. Right? That means what? 8 multiplied by 1 by 2. Right? That can be represented like this. So next time what will happen? 8 multiplied by 1 by 2. This thing multiplied by 1 by 2. Right? So next step what will happen? This thing will come here. 8 multiplied by 1 by 2. Multiplied by 1 by 2. Multiplied by 1 by 2. Right? In next step what will come? This entire thing and another. 8 multiplied by 1 by 2. 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 So this pattern will go on. Right? This pattern will go on. So what exactly we are doing here? See here, 8 by 2 power 1, 8 by 2 power 2, 8 by 2 power 3, 8 by 2 power 4 and go on, right? Go on, right? So how many times we will do this? How many times we will do this? Until we reach this, until we want to break this condition. So I will repeat this in this fashion until I became 1. If I became less than 1, then my condition, if my I is lesser than 1, we will break the execution, right? So this pattern will repeat until unless this condition fails. So this pattern will repeat until unless that condition will fails. Okay? If that condition satisfied, then we will execute. Otherwise, we will stop the execution of this for loop. So here, what exactly we got? We will generalize this 8 by 2 power 1, 8 by 2 power 2, 8 by 2 power 3 until what we will do. Here, what is my 8? 8 is n, right? 8 is my n, right? So 2 is common. 2 power 2, 2 power 3, 2 power 4, right? 2 is common. So instead of this 1, 2, 3 power value, we can represent it as 2 power k. So what exactly this is equal to? When this condition will fail, when this becomes 1, right? So what we derived, n by 2 power k equals to 1, then this condition will fail, right? So if you see, we can do this, n equals to 2 power k, right? So n equals to 2 power k. This can be represented as in logarithm fashion, right? So log n base 2 equals to k, right? We can, if you are confused, 2 power k equals to n. So this can be represented as log base 2 n equals to k. So what is my complexity of this for loop? We go of log base 2 n. So this is my complexity of this for loop, right? I hope everyone understood, right? We will see another example also. We will try to understand the loops so that it will be easy for you to understand. We will take another for loop. For example, same as this for loop, we will have, for example, I equals to n, I is greater than 1, okay, I minus, do something. So do something means some statement, set of statements that executed in one constant value, okay. So now, for example, my n is 5, I will be n, what will happen? 5 here, it will become 4, 3, 2, 1, right? So this will also execute n number of times. This for loop will execute n number of times. So why this require n number of times? Because when it reaches n number of times, this condition will fail, so that the for loop execution will stop. So we can say the complexity of this for loop is order of n, right? Now we will see another for loop, okay? For I equals to 1, I multiplied by I is lesser than n, I plus do something. This is my for loop. So what will be the complexity of this for loop? Let's do the same thing. Whatever exactly what we learned, we will try to apply the same thing. Let's imagine my n is 8, okay? Just imagine my n is 8. So what will be my I? Initially, my I value is 1, right? So after that, what will happen? What exactly here it is doing? I multiplied by I, right? That means 1 multiplied by 1, right? After that, I got incremented, and what will be the I value now? 2. What is this condition will do? 2 multiplied by 2. So our focus always should be on that condition, how to satisfy that condition, so that we will come up with our complexity properly, okay? So my I value will be 2. So 2 is lesser than or equals to 2. 8 is lesser than or equals to 8. Now it will become 3, right? So this will be true because 1 multiplied by 1 is lesser than or 8, right? 1 is smaller than 8, that is true. 2 multiplied by 2, 4 is lesser than 8, this is true. Now 3 multiplied by 3, what is the value? 9. Is 9 lesser than 8? False. So my condition failed here. So I will stop my execution of this for loop. So if my n increments, now if it is 16 or 100 or 1000 or 1 lakh, this pattern will go on, right? We will repeat until we satisfy this condition, right? So what exactly we are doing here? What exactly we are doing here? We are trying to match this n. We are trying to make this as n. So instead of this 3, 3 or 2, 2, we will generalize it. Let's imagine this is k. So k multiplied by k equals to n. So until we reach this point, we will repeat this condition. Once we reach this point, our condition will break so that our for loop will stop execution. So what this can be represented as k square equals to n, right? So this can be represented as k equals to root n, right? So my root n is the execution complexity of my this for loop. This can be big O of root n, right? So I hope you understood, right? Our focus always should be in our condition. How to break this condition? Okay. So to break this condition, how many times? What is the pattern? How we are doing the math? That is important. Here, what exactly we are doing? We are multiplying. So instead of to make this generalized format, if my n is 8, then if my I becomes 3, then my for loop will break. But if my n is 16 or 100 or something else, I need to repeat this pattern, right? I need to repeat this 4 by 4, 4 multiplied by 4, 5 multiplied by 5, like this. So instead of to calculate the complexity of this algorithm in a generalized way, because this n can be anything, right? Any number, not only 8. For our understanding, I just take an example of 8. We can replace this 8 with another number. So if we replace another number, we need to repeat this. If my n is 4, right, then I need only these two things, these two steps. But if my n is greater than highest, then I require, if my n is 8, I require at least 3 times I need to calculate. If my n is 10, I need to calculate another time also, right? So to make this, we are generalized to calculate our complexity. So instead of 3, I just simply replace the k. K multiplied by k equals to n. K square equals to n. So k can be root n. So what is the complexity of this program? Order of root n, right? We will see another example. Let's like j equals to 0. Okay, I have another for loop. I equals to 1. Okay, I is lesser than n. Okay, I plus plus. In this for loop, I am incrementing j value. J equals to j plus I. Okay. After this, do something. Okay. So if this is my program, this is my code for loop. So what is the complexity of this program? let's do the same thing. What is my, let's imagine, take n equals to something 5. Okay, what is my I is 1. What is my j? Initially 0. So what is my condition? I lesser than n. Okay, here we are implementing, let's make this as j. J is lesser than or equals to n. Let's j is lesser than or equals to n. So we are incrementing here. So what will happen? First I is 1, j is 0. So j is 0 is lesser than 5. So this statement will execute, and what will happen next? I will become 2. What will happen? J equals to j 0 plus 1, right? 0 here plus 2, right? 0 plus 1 basically. 0 plus 1, if 3, 0 plus 1 plus 2, 4, 0 plus 1 plus 2 plus 3, 5, 0 plus 1 plus 2 plus 3 plus 4. So this pattern will repeat, right? Right, this pattern will repeat. If you observe this one, what exactly we are doing? We are adding the numbers up to this value. To make this condition satisfy, what exactly we are doing? We are simply iterating and iterating through I, and we are adding up to the number n, right? So what exactly this means? This can be represented as, see, this is like n into n plus 1 by 2, right? For example, if you add 1 plus 2 plus 3 plus 3, what will be the value? 6. So if my n is 3, 3 multiplied by 4 by 2, right? 3 is my n, 3 plus 1 by 2. What is the answer? 6, right? So this can be represented as n into n plus 1 by 2. So already we used n for this input. Let's make this as another value, p. Just imagine p multiplied by p plus 1 by 2. So this is the formula of adding the numbers, right? P into p1 plus 1 by 2 up to what? Up to to break this condition, to make this as equals to n. So once this sum value becomes n, from next onwards it won't execute, right? So this can be, this is p square equals to n. So p can be root n. So the what is my complexity? Root n is the complexity for this for loop, this piece of code, right? So now we will take another example. Let's imagine I have for I equals to 0, I is lesser than n, I plus plus. For j equals to 0, j is lesser than n, j plus plus. Do something. So what is the complexity of this program? So see, we already know this. We already learned how many times it will repeat. It will repeat n times, and this will repeat, j loop also repeat n times. So how many times this will do? N multiplied by n. That means n square. So what is the complexity of this program? Big O of n square, right? Okay, so now we will see another for loop. So we will see another for loop. For I equals to 0, I is lesser than n, I plus plus. I have another inner loop, j equals to 1, j is lesser than I, okay, j equals to j multiplied by 2, okay, do something. Okay, for I equals to 0, let's do n. So for I equals to 0, this is my for loop, outer for loop, this is my inner loop. This is what exactly that is here. What is the complex of this? Let's see. For example, my n is 8. What is my I0? I value is 0 initially. What is my j value? 1. Right? So 1 is lesser than 8. Right? So what exactly we are doing? We are multiplying with 1 multiplied by 2. Right? For 0. 1 multiplied by 2, 2 is lesser than 8. So what exactly I am doing? Again one more time, I am multiplying with 2. So this value is 4. 4 is lesser than 8. 4 is lesser than, 4 is lesser than 8. So what we will do? We will multiply another time. Right? So this will come here, this will come here. So 8 is lesser than 8. Wrong. My loop will break, and what will happen? I value will increase 1. Right? So what exactly will happen? Again I value, j value become 1. So again it will repeat the same thing. Right? 1 multiplied by 2, same thing it will do. So what exactly we are doing? So this pattern will go up to, I value go up to n value. Right? This is normal for loop. So this for loop will execute n times, but inner for loop, the pattern to break this condition, what exactly happening here? What exactly happening here? This is 2 power 1, this is 2 power 2, this is 2 power 3. So this j loop is looping through power of 2 up to some value. Here in this case 3, but to make this generalized, this will going up to 2 power k times. Right? So this 2 power k up to what? Up to this, to make this condition satisfy. If 2 power k equals to n, then this for loop will, inner for loop will break. So this can be represented as what? Log base to n equals to k. So this is for inner for loop, but as you know, outer for loop is n, right? So what exactly we will do? N multiplied by, n is for outer loop. What is my inner loop? Log 2n. So this can be n log n, right? So my big O of n log n. This is my complexity of this for loop, right? This is my complexity of for loop. My outer for loop complexity is n, but my inner for loop complexity, by seeing this pattern, we came to know this can be ended up to, this for loop can be repeat up to log n times. So my inner loop is log n times and my outer loop is n times. So we will multiply both the things and we come up here, end up with n log n. So what is my complexity of this program? For loop n log n, right? in the same way how we done for loop, the same thing can be applicable for while loop also. Most of the time we will use for loop and while loop in our programming. So it is same as for loop. So let's imagine, for example, if I have while I is lesser than n, I equals to 1, do something. So what will be the complexity? Just do the same thing. If my n is 5, then what will happen? Initially my n is 1, I is 1, 2, 3, 4, 5. So this, to make this condition satisfy, how many times I need to repeat myself? I need to repeat myself 5 times. So what is the complexity of this while loop? Bq of n. Okay. Now we will see another example. So we will keep this I less than equals to n, but this time we will increment I equals to I multiplied by 2. Do something. Okay. So what will be the complexity of this program? This is same as for loop. Anyone can guess? This can be represented as, maybe you can, if I equals to 1, what is my condition? I is lesser than n. What is the value I am incrementing? I equals to I multiplied by 2. So do something, right? We calculated this previously, and you can do the same thing for here, right? So for example, for our understanding, let me call it out, let me explain. So for example, if my n value is 8, so my I value is initially 1. After that, what I am doing? I am multiplying with 2. Up to what? Up to what I need to do this? I need to repeat myself to make this condition break. So next time 1 by 2, 1 multiplied by 2, 2 is lesser than 8. This is true. So what I will do? I will repeat myself to make it as false. So what it will come? 4. 4 is lesser than 8. So what I will do? I will repeat myself another time. So this value is 8. So is 8 is lesser than 8? False. So I will stop after this condition. Right? So what exactly we done? This can be 2 power 1, 2 power 2, 2 power 3. If my n is 8, then I will do 3 times by using 3, 2 power 3. If my n increases, I will repeat this pattern some more times based on my n. But I need to repeat in this fashion. So what exactly 2 is common? If you say 2 is common. So what exactly is changing? This power. So until this condition satisfies, I need to power up myself. So let's imagine, make it as generalized 2 power k. So when 2 power k equals to n, then I will break my while loop. So this can be represented as how? In logarithmic equation, log n equals to k. So what we are left with? So what is my complexity of this? Bq of log n base 2. Right? This is same as our for loop. Nothing new, but instead of for, here we have while. But the condition is same, and what exactly how we are incrementing. So if you observe, our complexity majorly depending on the condition of your loop and how you are incrementing the value. Based on those two things, our complexity is changing, right? So I want you to try on your own also, so that it will be very good for your understanding purpose. Do the same for loops, take whatever for loops you want. You can initialize with some value and place some conditions and explore yourself to understand this complexity, how to calculate the complexity, so that it will be very good, it will be very helpful for you.